Okay, this is the third part of our review for, it's a semester exam review, but we're also reviewing it for our quiz right now. I've got problems 1 through 11 done prior, 12 we're skipping for now. 13 asks us to let f be some function. It just starts out like a nice harmless polynomial, but then throws this at us, which is a little bit of a curveball compared to what we're used to. But it says k is constant. And then we're just given this information about the graph on what intervals is the graph of the function, are the y values decreasing. And that's where I'm going to say, speak calculus to me. What's that mean if f is decreasing in calculus terms? Slope is negative. That's algebra terms. Now let's go calculus terms. First derivative is negative. What we want to do is we want to find when f prime of x is less than 0. So of course we're going to find f prime x, which is 3x squared minus 8x plus 5. How about derivative of k though? K is a constant. Therefore the derivative of k is 0. Okay, so we got it right then. This guy I want to set equal to 0. If I do that, I'm going to factor. I need factors of 15 that add up to be negative 8, negative 5, negative 3. This guy will factor into 3x and a minus 1, and this would be x and a minus 5. So I get x is 5/3 and x is 1. And that's where the graph levels off. Now what we normally do if we're just calculus robots right now, we're going to come up here, we're going to make a y prime chart, we're going to put 1 here, slope is 0, we're going to put 5/3 here, first derivative or slope is 0, and now we're going to test zones. Like I put in 0, and I get 0, 0, plus 5, it's positive. I'm going to put in 3, 3's over here. And I get 9, 27, minus 24 plus 5, that's positive. And I can put in 1 1/3 or something like that, and I'm going to get negative. Do I really need to do that when I know this is a positive cubic and it has 2 places where the slope levels off? Don't I know this curve looks like that? Don't I know it goes from positive to negative to positive? So let's not get so high on ourselves calculus-wise that we forget pre-calculus. Oh, I knew it looks like that, therefore it's plus minus plus. What interval is it decreasing on? From not negative, but from 1 to 5/3. Okay, that's our interval of decrease. Okay, question B. On what intervals is the graph of f concave upward? Talk calculus to me. When is the second derivative positive? So this is just saying when is f double prime of x greater than 0? So f double prime of x is, this is easy enough, derivative of this, 6x minus 8. When is 6x minus 8 greater than 0? When x is greater than 8/6 or when x is greater than 4/3. On what interval is that? 4/3 to infinity. Okay. Pretty simple. Now this next problem at this point isn't a calculus point, other than we're going to use some of our information from A. We're going to find the value of k for which f has 7 as its relative maximum. Now here's what I know about the graph of f. The graph of f looks like something like this. But I want its relative maximum to be 7. Where does its relative maximum occur? What x value does its maximum occur at? 1. Where it went up and came back down is at 1. Okay. So what k is going to do is just going to, when we add a constant onto a function, it just raises it or lowers it. So we're going to have this curve. This curve might exist down here, and we want to put it, might exist down low, and we want to put it up higher, so we have to raise it up with the value k. So here's what I know. I know I want y to end up being 7 when x is 1, so that would be 1 to the 3rd minus 4 times 1 squared plus 5 times 1 plus k. Does that make sense? I'm forcing my graph to go through 1, 7 based on the value of k. So couldn't be any easier than this. That's 1 minus 4 plus 5 plus k, or that's 7 equals 6 minus 4, 2 plus k. K value needs to be 5. A little different than things we've done, but I think certainly well within our reach. Okay, questions there? All right. Now, when I feel 14 is a fine problem for the exam when you have 100 minutes and this is all you've got, I think 14 is a little bit of a stretch for the quiz tomorrow. Maybe a portion of 14 would be fine, but the full 14 took me too long on this. We're also getting into the types of derivatives that gave us some trouble on the last test. This is like number 2 from our last test when we find the derivatives of this. And we're going to need to find both derivatives right away just for acceleration. It'd be nice if they'd ease us in and talk velocity for a minute. Okay, a particle moves on the x-axis, so it's moving right, left, one way or the other, or both, so that its position at any time t is greater than or equal to 0 is given by the following function. Here we go. That is a t, and about 3 times I've looked at that, doing it, and thought that was a -1. So hopefully I don't do that again. Find the acceleration when t equals 0. Talk calculus to me. Find the acceleration. Second derivative. So first derivative, we're going to need it later, and we got to get it to find the second derivative anyway. I'm just going to call v for velocity. You could call it x prime if you wanted. Product rule. We're going to take our time. We're going to get this right. This has caused us problems. First, 4t times derivative of the second. The derivative of e to the wants to be e to the times the inside derivative. The derivative of negative t with respect to t is -1. That's first times derivative of second plus derivative of first, just 4 times plain old second, e to the negative t. Or, well, just get -4t e to the negative t plus 4e to the negative t. And I know I probably want that factored at some point, so I'm going to factor it now. I'm going to factor out the -4, and I'm going to factor out an e to the negative t, and I'm left with just plain t, and I'm left with a -1 if I factor out a negative. Why is that useful? It may not be useful for finding the second derivative, but it tells me right now I know when the velocity is 0, when t is 1. That's going to be useful later. So on to the second derivative, or acceleration. Now, if I was to go back up to here and find the second derivative of this, is it clear? I've still got to do product rule here. And I got to do product rule here. I'm just going to do it from here. So I'm going to take the second derivative based on this product rule. I want the just plain first function, -4e to the negative t, times the derivative of the second function, which is just 1, plus the derivative of the first function. Derivative of -4e to the negative t is going to be -4. e2, though, wants to stay e2, but times the inside derivative, -1, times the just plain second function. All right. A little bit of cleaning up here makes this -4e to the negative t. This would be plus 4e to the negative t times t minus 1. And the last thing here I'd want to do is distribute. I want to factor. I'm going to factor out the -4 and an e to the negative t. Or you could just factor out a 4e to the negative t, leave the negative there. They both have that. And that leaves me with, when I factor out a -4e to the negative t, I just get a 1. And I just get a plus. I still have the t minus 1. Does that look right? Where am I? I got a mistake somewhere, don't I? What would it be? 1 minus. It should be, oh, because I factored out a negative, thank you. Minus all of t minus 1. I knew that didn't seem right. Okay, so that gets me negative 4e to the negative t times, what do I get? I end up getting a 2, positive 1 and a positive 1, 2 minus t. Okay. All right, is that okay? Now it says, find the acceleration, so I want a of 0. A of 0 is put 0 in, and I get negative 4 e to the negative 0th times 2 minus 0, or I get negative 4 times 1 times 2, negative 8. You can put the e to the negative t in the denominator if you want to. Okay. So there's a load going on right there. Now, find the velocity of the particle when the acceleration is 0. So before I find the velocity, I need to know when acceleration is 0. Is that a of 0, or is that a of t equals 0? Yeah, I want a of t. When does that equal 0? So when does this guy equal 0? When t equals 2. Right? But I want the velocity when the acceleration is 0, or I want the velocity at time 2. So I want v of 2 now. V of 2, I'm going to put it in right here, and I get negative 4 e to the negative 2nd times 2 minus 1, or negative 4 times 1 on e to the 2nd. Negative 4 e to the negative 2nd if you like. Okay? All right. And we actually did we didn't specialize in problems like this, but we did a couple problems like this very, very early on. Find the total distance traveled of the particle from 0 to 3. So what would be wrong with this? What would be wrong with putting t equals 0 into my position, find out where I am, put 3 in for t, find out where I am then, and then subtract them. Like if I start at 3 and I end at 7, haven't I gone 4? Yep,
That's only the displacement.
That's the displacement. That's just, maybe I went 73 to the right and then came back. So what am I looking for? I'm looking for when my velocity changes sign. I want to know, did my particle move to the right, move back to the left? So what I want to know is, here's what I'm curious about, is when is velocity of t equal to 0? Because that's when it might be changing signs. Well, velocity of t, I'm just going to rewrite it down here. So that's just asking, when is negative 4 e to the negative t times t minus 1 equal to 0? When t equals 1. Now, I could check and see if it's changing signs, but think about it for a minute. Let's say at time 0 I'm here and I went to the right 7. And then I went to the right again 2. I could still just take 7 plus 2. Or if I went to the left 2, it would still be 7 plus 2. So what I'm going to do is I'm going to find out where am I at time 0, where am I at time 1, when I might switch directions, and then where am I at time 3. So I want x of 0. X of 0 is 4 times 0 e to the negative 0, which is 0. I want x of 1, which is 4 times 1 e to the negative 1st, which is 4 on e. And I want x of 3. Why not x of 2? Not changing directions at 2, am I? So I want my starts, and any place I'm going to change directions. So x of 3 would be 4 times 3 e to the negative 3rd, or 12 on e to the 3rd. Now we can analyze when am I moving to the right, when am I moving to the left, but basically I want to know how far did I move from here to here. Oh, well, from here to here I moved, if I call that distance 1, that's 4 on e. Then I moved from 4 on E to 12 on E to the third. I don't even know if that's right. Maybe I continue in the same. Maybe I went to the right, paused, and then went to the right some more. I just need to know how far I went. If I call that distance 2, how do I find the distance between 2 points? Let's say 7 and 11. How far are they apart? We subtract. But what if I say 7 minus 11 or 11 minus 7? One gives me 4, one gives me negative 4. I only want the positive version of that, right? So would it be okay to say that distance 2 is absolute value of 4 on E minus 12 on E to the third? You don't have to do that. You can figure out which one to subtract. You can figure out which one's bigger. You can change these things into decimals. And you know which one's bigger and which order to subtract. So our total distance would be, I went 4 on E, and then then the particle went an additional 4 on E minus 12 on E to the third's absolute value. And somebody certainly wrote that down from yesterday, because I don't have it sitting in front of me. As a rounded decimal, that is what? 346? That sounds right. Somebody else had that written down. So we'd round it there. If we want an exact answer, it's that. Okay, hope that is helpful. Again, I would have to modify that problem quite a bit if I was going to feel comfortable putting that one on the quiz tomorrow, but most definitely you'll have something like this to wrap up your final. That will be the last question on your final when you come back in January.